Okay, welcome everybody to this new video. I'm the successful electronics which posts on great electronic content, and I want to tell you welcome back. I'm very sorry for not posting videos a long time ago, but now I'm going to be discussing in this video the 27 megahertz transceiver. Yeah, I'm going to be talking about the transmitter and the receiver, the quality, the voltage which is needed to be able to power it on, and every detail which you have to understand when you're dealing with this transceivers model. Now actually these transceivers models are used in making, I will see curls are used in making, I will see planes. We also have different types of transceivers, so we also have different types of receivers and transmitters, and in this video I'm actually going to be telling you the types we have, and I'm also going to be discussing greatly in this particular 27 megahertz 4-channel transmitter and receiver. I would like you to stick around to the end of this video to have great insight and understand what I'm actually talking about, and I want you to subscribe to this channel if you haven't subscribed to this channel. Support me on Patreon for more interesting electronics content like this, and if you also like playing games, you can go to my other channel at Electrocode Mobile, which I post mainly on games. So without wasting much time, let's jump. First type, the type which I'm holding here, which is the 4-channel. This is actually the receiver, and it's a model of XN507ROX. This is the particular model which I have. You can see it right here, and this is the this is 27 megahertz, which is colored, and this is the one which is shaded, which is the one which is working on. We also have different types like 40 megahertz type. We have the 49 megahertz type frequency. There are different types of transmitter and receivers, but in this video I'm actually going to be talking about basically the ones that are working on the frequency of 27 megahertz. Okay, now right here there's the receiver which I have here. You can see the IC right here. This is the IC, it's back of here. You can see the picture below. This is the IC right here, which does most of the job, which does 100% of the job of the receiving structure. And actually the name of the IC is actually I write it on the paper right here. I can't see it clearly right here, but it's really tiny, but I don't think you guys will see it right here. So this is the name if you want to know the name. Actually it's the MX1508RX. Yeah, that's the name of the IC which is built in this receiver, which does most and which does everything on this particular board. And you can see this is the antenna, and I got this from AliExpress, and it was very cheap. It's about $1, which I got this, and in our naira conversion is actually 479 naira. Yeah, in our naira conversion in my country, but in US I will precisely take it as $1 or $2. Yeah, actually not $1, because right now $1 is about 767 naira in our country, so it's really costly. No, not really costly, really cheap. So actually this is the receiver, which and you can see the IC right here. It do most of the jobs, and actually I'm also going to be showing you the transmitter, which do also one part of the job. Actually I added the antenna to make it more receiving, so that actually the receiver is actually going to be receiving these signals from a kind of far range for connection. In case I'm making a kind of RC car and I just want to make it that it's gonna have a steering, and actually going to be having a back motor which is going to be moving the car forward, and actually the steering is actually the one which is going to make it move left to right. And I added this antenna which can be extended to a certain length so that it can be able to catch the signal even in long range. Actually in this type of transmitter receiver, the actual range which is built in and which is expected from it is actually about 50 meters. Yeah, not more than 50 meters, about 50 meters or less than 50 meters. Yeah, that's what you're gonna get from this transmitter receiver. But me adding a kind of long antenna and making it more powerful, it can be able to be adding kind of about 60 meters or 55 meters. Yeah, I just added a more range to it so that it can be able to catch my signal even though I'm in far distance. Okay, now you can see the antenna now, and I connect a long wire. I put it in a shield which other frequencies, other signals cannot be able to distort it. And you can see that I placed the transmitter on a carton, on the cardboard actually, and this is the switch which turns the circuit on and also off the circuit. Actually in the next clip I'm actually showing you how to connect this, and actually this transmitter actually works in about 4.5 to 5 volt. Yeah, it does pass that. You know, when you get, I don't think it reaches 5 volt, because when you reach 5 volt, this chip built in it get start acquiring some kind of heat. And yes, you can see the controls right here. This is the 4-channel controls. This is the it says the front and the back, and this is the left and the right. It's basically built for building and receivers, but in this video I'm actually going to just be testing it, connecting the outputs to a LED, and actually going to power in this transmitter, and I'm going to be staying in a kind of far range, and you're going to see how it actually transmits its frequency, and it's actually going to on the bulb when I press the particular switch according to the way I connect it. As you can see in the receiver right here, it have a kind of 4-channel. Yeah, there's the 4-channel, which I hot glue it so that it cannot be able to cut and it to be firm, and it's have 4-channel, and it also have the positive and the negative for powering it. But I think this actually receivers is actually working in a kind of 3.7 to 4.5 volt. Yeah, 3.7 to 4.5 volt is a really good one, and it's gonna be DC, not AC. DC. So actually in the next clip right now, I'm gonna be showing you how to connect the outputs to a bulb, actually a LED, and actually powering powering the transmitter. And I put a battery holder right here. This is a battery holder right here, which outputs about 3.7 to 4.2 volts, which actually powers the whole setup of the transmitter. Now actually there are different types of transmitter and receiver. Now they have another type of transmitter and receiver which actually works on high frequencies and high volume, which are actually connected to a kind of Arduino programming, and you need to program the Arduino, or what to do. Those kind of receivers are modules which cannot work on its own, that needs kind of programming or kind of Arduino board which works in hand with the module. Now there are actually other types of transmitter and receivers, and we also have a RF transmitter and receiver. Those ones works on higher frequencies and higher range, which can be able to make kind of airplanes or receivers, which most of our electronics toys works on. So actually that are the different types of categories of this transmitter and receiver. And actually the frequency differs. They are having different frequencies. Some have higher frequency, some have lower frequency. But actually this module which I'm talking about in this video is actually 27 megahertz. That's the peak of the frequency which it normally operates on, and this is what it operates on in the transmitter and the receiver. And anything or any frequency more than that, or which is actually not the same, it will not respond to that right now. So actually if you buy a receiver, you have to buy the transmitter, which actually works in hand with the receiver for it to be able to communicate. Yeah, as I said earlier, the model I have here is the XN507RX. You can see it right here. I don't know if you really see it, but this is the model number here, but I don't know if you see it. It's not getting kind of focused, but I really sure to post it on the screen for you to be able to have more details about it. You can go search it on Google if you don't really understand the model. You can go search the model number which I mentioned, that you can get more insight about it. So actually, without wasting much time, I'm actually going to move into the connections, how to connect it to a LED, how to connect the outputs, how to connect it to the battery, how to make it work, and actually we're going to be testing the range right here. Don't forget to subscribe to this channel, and let's go into the connection. Stay tuned. Okay, welcome back. Actually, I'm not using the Arduino for anything in this video. I'm actually just collecting a 5 volt from the Arduino to power the circuit. So this is not any programming code or something. The Arduino is not working on this circuit. Actually, I'm just branching some kind of powers from the Arduino. I connected the USB to my laptop, then I collect 5 volts from the Arduino right here. It's actually not doing any programming work. I just assembled the Arduino to just collect power. So as you can see here, this is the receiver. This is the receiver, and these are the channels. Actually, it's a 4-channel 27 megahertz receiver, and you can see these receivers are then connected to a LED, which I'm going to be using in this video. I'm going to be testing with the LED in this video. Actually, you can use this receiver to connect to anything you want to connect to. It can be maybe moto, it can be maybe DC moto or any kind of stuff, but in this video actually I'm just connecting it to a LED to test. Yeah, actually now this is the transmitter, which has the 4-channel buttons to connect, and this is the antenna. I removed it from the big antenna which I connected last time, and because this is just a close range stuff, so I wish to just connect it I just wish to leave it with the new with just the antenna which comes with it. Actually these were scattered, so I have to solder them up. So actually here we are, let's test it out. Okay, now these are connected completely, so without wasting much time I would like us to test it. So now these bulbs are connected to each channel of the receiver. Now these are the channel which are connected to the LED. You can see them right here. They are connected to the LED, and you can see the other one is also connected to the LED. You can see it right here. Okay, now without wasting much of time, I'm going to be pressing the buttons, and it's going to react to each channel. Okay, now these channels are meant to be front and back, and when I press the button for the front, it's actually going to be sending a particular voltage which is positive and negative. But when I press the other button in a reverse mode, it's actually going to send in the reverse of that positive and negative. It's not going to be positive and negative again. It's going to be switched. It's going to be switched, and it's going to be negative and positive. Yeah, that's actually how it works. That's actually how it works in connecting it to a motor. You know, when you connect the motor, positive and negative, to a DC motor, it's actually going to turn in a particular manner. But when you reverse the pins, reverse the positive and negative, reverse them in a reverse manner, it's actually going to make the motor, the DC motor, to turn in different direction. So that's how actually the motor goes front and back. So now in this circuit, I actually connected it in correctly in different channels. These are 4 channels, so I connected in the 2 channels which are the plus and minus and plus and minus. Yeah, so now actually I'm going to be pressing the button, and as you can see, the red light turns on when I press the button. As you can see, when I press the button, the red light turns. As you can see, there also a LED right here which also indicates that a button has been pushed in this transmitter. Now when I press the other phase of the channel, when I press one of the particular buttons, it's actually going to turn the other LED, because the other LED is connected to the other channel of the receiver output. As you can see, when I press the LED, when I press the switch, that's going to go to turn on the LED, and when I release, it's off. So actually this is transmitting the frequency to the receiver, and when the receiver receives the power, receive the frequency, and understand that this is the kind of frequency which is need to be received, it actually turn on the LED during the instruction which is sent. This is how it's connected to a DC motor, a RC motor, airplanes, and any kind of stuff which are kind of RC stuff. So here you can see, when I press the LED, when I press the button, that's going to turn on the LED which is connected to that particular channel, and when I press the other button, that's going to turn on the other LED which is connected to the other channel. This button is for this channel. It's for a particular channel. These buttons are different channels. This is for front, and this is actually for front and back, and this is actually for left and right. So you can see it here. It's actually for front. This is F right here, and this is B right here. And you can see this is right here. This is arrow, and this is L right here, which actually means front and back. So you can see when I press it, it's going to turn on the channel which is connected to that particular switch button side. When I press the other button channel, it's actually going to turn it on. So this is the practical way of connecting it. I connected the positive and negative to a 5 volts. This is sharing a particular place, and as you can see, this is ground. Don't think if you can see it well. This is ground which is connected to, and this is 5 volts which I also connected to the receiver and transmitter for power source. So this is now connected to the negative. The ground is connected to the negative. As you can see, the wire is black, and the positive is connected. The 5 volt positive is connected to the 2 red wires which are from the transmitter and the receiver. So once more, let's just test test it again and see how it functions. So actually this is for one channel and this is for the second channel. So when I press this one, it actually turns the bulb on. When I press the other, it turns the bulb. Really amazing. So this is how you want to test. If you want to test this at your home, I'm going to leave a schematic of how to connect everything in the screen below. And if you want to test this at your home, free do to test it. And I hope you really enjoy this video. Without wasting much of time, let's go to the conclusion. Okay, welcome back from this short break. Thank you very much for watching. If you really like this video, don't forget to subscribe to this channel, give me a thumbs up, and also support me on Patreon for more interesting electronic content like this. Until then, I'll see you in the next one. Bye for now.